This problem involves a dataset containing information described by two different characteristics or features. Think of it like describing a person. You might use height and weight as two features. The goal is to find the best way to group similar data points together using a Gaussian mixture model. The Bayesian information criterion, BIC, is a way to measure how well a model fits the data while also penalizing the model for being too complex. Imagine you're trying to fit a curve to a scatter plot. A simple straight line might not fit well, but a highly complex curve might overfit the data and not generalize well to new points. The BIC scores show how good different Gaussian mixture models are when using 1, 2, 3, or 4 groups, components. Lower BIC scores are better. The numbers shown indicate the BIC value for each number of components, k. For example, a BIC of 120 is better than a BIC of 150. This question asks us to analyze the provided BIC scores to determine which of several statements correctly describes the optimal number of components for the Gaussian mixture model. It's like a multiple-choice question testing your understanding of the BIC score's role in model selection. This section sets the stage for the problem. It introduces the use of scikit-learn's Gaussian mixture, a machine learning technique used to model data using a mixture of Gaussian distributions. The goal is to determine the optimal number of components, clusters, in the model using the Bayesian information criterion, BIC. We are given BIC scores for different numbers of components, k, and we'll learn how to interpret them to find the best model. This part presents multiple-choice questions based on the BIC scores provided earlier. We'll use our understanding of the BIC to evaluate each statement and determine which ones are true. Remember that a lower BIC score indicates a better model in terms of balancing goodness of fit and model complexity. This is a crucial step in model selection, where we use the BIC score to compare different models. This is where we get to test your understanding. Each option presents a different interpretation of the results, and we need to carefully consider the BIC values to select the correct options. Let's analyze each option individually and eliminate the incorrect ones. Okay, so we're working with a dataset that has two features. This means each data point is described by two values. Think of it like plotting points on a simple graph. Each point has an x and a y coordinate. Right, we're using something called the Bayesian information criterion, or BIC for short, to figure out the best model. The BIC helps us choose the model that best fits our data without being too complex. A lower BIC score is better. It's a kind of trade-off between accuracy and simplicity. We're trying to avoid something called overfitting, where the model learns the training data too well, but performs poorly on new, unseen data. Here, we're trying a Gaussian mixture model with just one component, k equals 1. The BIC score is 150. This is our starting point, our baseline. Think of the model as a single blob trying to represent all the data. Now let's try a model with two components, k equals 2. The BIC score has dropped significantly to 120. This means the two-component model represents the data better and more efficiently than the one-component model. Increasing to 3 components, k equals 3. The BIC increases slightly to 125. This suggests that adding a third component doesn't significantly improve the model's representation of data and may be slightly redundant. Finally, with 4 components, k equals 4, the BIC jumps to 130. This is higher than the BIC for 2 components. This suggests overfitting. We're making the model unnecessarily complicated, and it's not generalizing well. This problem involves analyzing data with 2 different characteristics or features for each data point. Imagine each data point as a dot on a graph with 2 axes. The goal is to find the best way to group these dots based on their similarity. The Bayesian information criterion, BIC, is a score used to evaluate how well a model fits the data while penalizing model complexity. A lower BIC is better. It helps us choose the best model among multiple options. In this case, we're looking at different Gaussian mixture models with varying numbers of groups, components. This line indicates that when the Gaussian mixture model uses only one group, k equals 1, to cluster the data, the BIC score is 150. This is a relatively high score. Here, the model uses 2 groups, K equals 2, and the BIC score is 120, which is significantly lower than when using one group. This suggests that two groups might be a better fit for the data. With 3 groups, K equals 3, the BIC score goes up to 125, which is higher than the score with 2 groups. This implies that adding more groups doesn't necessarily improve the model. Using 4 groups, K equals 4, the BIC score increases even further to 130. The increasing BIC scores indicate that the model is becoming too complex and may be overfitting the data.